So this is lecture 49, and in this lecture we are going to discuss about the reconstruction of the band limited signal, okay, and using the interpolator, okay. So reconstruction is nothing else the recovery of the signal. Now अगर मैं बात करूं रिकवरी ऑफ द सिग्नल, तो उसके लिए जो पहली कंडीशन थी कि जब हम मैसेज अपना ट्रांसमिट कर रहे हैं, सिग्नल ट्रांसमिट कर रहे हैं, मैसेज सिग्नल, उसको क्या फॉलो करना चाहिए? सैम्पलिंग थ्योरम, ओके। अगर वो सैम्पलिंग थ्योरम फॉलो कर रहे हैं सिग्नल, तो उस केस में वी कैन इजीली रिकवर द आर ट्रांसमिटेड सिग्नल, ओके। ये हमें पता है। चलिए, so according to this sampling theorem, कि rather than sending the overall the signal, हम क्या करते हैं? We have sent some set of samples value of the signal, okay, जो continuous signal है उसकी set of samples values को हम transmit करते हैं, okay, और you can say interpolation करते हैं. So interpolation is a commonly used procedure for reconstructing a signal from a samples. Either your signal can be approximately or exactly. Okay. So now in this case, interpolation in this adjacent sample, adjacent sample means उसके आसपास वाले sample, sample points are joined by a straight line. Are referred to as the linear interpolation. So for example, suppose we have a signal, okay, and we have the sample values like this. Samples values हैं जो हमारे पास अवेलेबल. आई एम जस्ट ड्रॉइंग द रैंडम, ओके, रैंडमली कोई सिग्नल है उसको ड्रॉ कर रहा हूँ. ये कोई है. So according to the definition, जो samples वैल्यू थे उनको हम क्या करते हैं? एक स्ट्रेट लाइन से ड्रॉ कर देते हैं, ओके. सो कुछ ऐसे ऐसे so the recovered signal is known as the XT. Now this is a process कि जो भी samples values हैं उनको हमने क्या कर दिया? एक स्ट्रेट लाइन से कनेक्ट कर दिया, और यू कैन से कि जो भी सैंपल्स हैं उनको हम एक हार्ड लाइन से हमने उनको कनेक्ट कर दिया आपस में, ओके, सो दैट वी विल गेट द योर ओरिजिनल सिग्नल. नाउ इफ यू नो, सपोज जैसा कि मैंने आपको सैम्पलिंग के बताया था, ओके, According to this diagram, you can understand, okay, what is the sampling and how we are going to reconstruct our signal at the receiver side. So obviously this is the input signal. Now when we do the sampling, okay, let's see, this is a sampling for sampler function, and that is nothing else the delta function. We have already seen this, and equal to minus infinity to infinity delta t minus nt. Okay, so at this point we are getting xt multiplying this pt, and here let's see, we are getting the xpt in time domain and xpj omega in your frequency domain. Let's see, this is your one low pass filter over here. So this, so transfer function, this filter is ht, or impulse response in frequency domains is this h of j omega. So at this end you are getting the your xrt or xrj omega. You can see over here at this point you are getting this value. So this is nothing else the a system for sampling and reconstruction. Okay, so at this point the sampling is done with the help of this pt. Okay, and here the reconstruction is going with the help of your h omega. Chaliye. So according to this is nothing else the low pass filter. So if I talk about according to this block diagram, you can write it down, this received signal xrt. If I talk about this xrt, so this xrt is nothing else the xpt convolution with the ht. We already discussed this point. Okay, so this xrt पे क्या हो रहा है, जो भी वैल्यू हमारे पास xpt यहाँ पे आ रही है, and it is convolving with this low pass filter transfer function ht, जो उसका scope है. ht is your impulse response of the your low pass filter. Now इसी को हम कैसे लिख सकते हैं, इस xrt equal to n equal to minus infinity to infinity x and t means जो हमारा मैसेज सिग्नल है h t minus n t, that is nothing as the convolution definition. Okay, this is your n t. We already discussed about this equation, how to take the convolution of the. So इससे क्या मिल जाएगा हमें, ये मिल जाएगा. Now remember, and this is important point you have to remember, okay, for the ideal low pass filter, the impulse response okay, so for this impulse response generally we are ht equal to omega ct upon pi sync function of omega ct. So if you remember, अगर आपको याद हो, when we were doing this फोरियर ट्रांसफॉर्म, उस फोरियर ट्रांसफॉर्म में हमने इम्पल्स सिग्नल का जो था फोरियर कैलकुलेट किया था. ओके, जो हमारा इम्पल्स ट्रेन थी आपके, मींस सपोज यू हैव अ इन दिस वे. So in that case we have calculated, and that is nothing else was coming the sync function. So same हमने क्या किया कि आइडियल सिचुएशन ली. आइडियल मीन्स कुछ हमने ऐसी सिचुएशन ली कि जो हमारा फिल्टर है, लो पास फिल्टर, उसका रिस्पॉन्स ये है. सो इन दैट केस एच टी इज कमिंग नथिंग एल्स दी, अगर मैं बोलूं एच टी कहाँ से आ रहा होगा, इनवर्स फोरियर ट्रांसफॉर्म ऑफ दी और एच ऑफ j omega. Okay, so in that case we were getting the inverse Fourier transform is a sinc function, not Fourier transform, inverse Fourier transform. So with the help of this condition you can write it down, x rt equal to n equal to minus infinity to infinity x of nt omega ct upon pi is constant, sinc ओमेगा सी टी की जगह क्या हो जाएगा, टी माइनस एन टी. सो यूज दिस फंक्शन इन दिस वैल्यू. So let's see, this is equation number 1, equation number 2, equation number 3. Now according to this equation number 3, you can see that omega c is equal to omega s by 2. ओके, सैम्पलिंग फ्रीक्वेंसी डिवाइड बाय 2. सो किस तरह से हमें ये सिग्नल रिकंस्ट्रक्ट हो रहा है, अगर हमारे पास बोलूं कि एक तरह से क्या था, अगर मैं आपको यहाँ पे फिगर के थ्रू डिजाइन करना चाहूँ, तो वी हैव दिस सिग्नल लाइक दिस इज, और I can do one thing. Let's see, this is our signal. Okay, this is your xt and this is your t domain. Now what after sampling we are getting some values. अगर मैं यहाँ पे values डिजाइन करना चाहूँ तो कुछ values ऐसे आएंगे. इनको कंबाइन अगर हम करेंगे so we will get same structure जैसा इसका है, same structure after sampling. Now same in the case of this sync function, क्योंकि ultimately हमारा जो response आ रहा है वो क्या आ रहा है, sync. So I'm just drawing the so anyhow you're getting in this way sync function. So different sync function you are getting over here. यहाँ भी कुछ आ रहा होगा. So in this way you were getting the sync function over here and you are calculating the response of the your received signal. So this is nothing else your xrt and these are the your sync function जो आप देख रहे हैं. So this is nothing else the your interpolation using the sync function. Okay, you can write it down. Interpolation using the sync function. So conclusion point over here, interpolation in or by equation 3. What was the equation 3? That was your equation 3. Okay. That is using the impulse response of an ideal low pass filter. Ideal low pass filter is commonly referred to as band limited interpolation, interpolation, since it implements exact reconstruction if xt is band limited and the sampling frequency satisfies condition of the sampling theorem. The important point, sampling theorem उसको satisfy करना चाहिए. In the case of interpolation, if I tell you that is the main formula we are using. Okay, how we are going to xrt is nothing else but the received signal. Okay, so this block diagram is important in the case of the sampling and reconstruction. Okay, and how you are going to use the interpolator? So you are going to interpolator as a sync function. Okay, so in this direction, in this way, you can achieve the your desired or required